So this is Notes 13, page 10. This is a review, and you can tell I was hoping to have a review session, but I'm going to go ahead and go over these in case that doesn't happen. I need to change this problem, and it just didn't work out the way I wanted it to. So it's going to be a little weird. Change the exponent on this x to x to the 0. Just leave it that way. Now I started it for you. We're going to factor this completely, leave negative exponents. GCF is x to the negative 1/3. Okay, so finish it from here. So turn the video off, see if you can finish it. Then turn the video back on and check your answer. So I'm going to go ahead and finish it. So when you take out x to the negative 1/3, you got to ask x to the negative 1/3 times what will give me the 2x to the 1/3 back. And that would be 2x to the 2/3, because when you're multiplying the same base, you add the exponents. Negative 1/3 plus 2/3 gives you positive 1/3. And then this is the weird one, this x to the 0. But think about it. X to the negative 1/3 times x to the positive 1/3 would give you x to the 0. And then the easy part's the minus 20. All right, are you done? Remember, make sure every factor is prime. And you should be looking at this and going, it has 3 terms. The last term's a constant. Ooh, and this exponent is twice as big as this one. Ooh, this might be in quadratic form. I might be able to use substitution. So I'm going to introduce a substitute variable u. And I'm going to let u be x to the 1/3. It's always the smaller of the 2 exponents. So if u is x to the 1/3, so we know that x to the 2/3 is the same as x to the 1/3 squared, because power to power you multiply, and x to the 1/3 is u. So x to the 2/3 is u squared. So this is x to the negative 1/3 times 2u squared plus 3u minus 20. And the substitute variable just made this problem look easier. This just looks like a FOIL in reverse. If you could factor this without the substitute variable, if you see the pattern, what's going on, go for it. So we got x to the negative 1/3 carrying my GCF. I know it's 2u and u. All right. I know it's 1 plus and 1 minus, so the outer and inner will subtract. Okay. I know last times the last has to be 20. You multiply to be 20. 20 times 1, I'm not really liking. 10 times 2 is impossible, because if I try 10 times 2, I either have to put the 10 here or the 2 here, which creates a GCF. I took out the GCF. That's impossible. And then there's 4 times 5. I'm going to try the 4 times 5 first, and I know I can't put the 4 here because that creates a GCF. So I'm going to try it here and put the 5 there. And then when I do outer, I get 8u. And when I do inner, I get 5u. And I know they subtract, so I know I'm onto something here, because 8 minus 5 is 3u. So I just need to make sure the 5 winds up being the negative 1 plus. All right. And then one last thing to do, I didn't leave myself much space. U was just a substitute variable to help us see what was going on. So I need to factor this using x in the original variable. So u, and you should always write down what your substitute variable is standing in for, because you're going to have to substitute back. U is standing in for x to the 1/3. So that would be 2x to the 1/3 minus 5 times x to the 1/3 plus 4. Didn't leave myself enough room at all. Okay, and like I said, if you could realize, hey, if that's 2x to the 2/3, then that has to factor x to the 1/3, x to the 1/3, If you can factor this without the substitute variable, go for it. All right. I'm sorry that's so tiny. It's x to the negative 1/3 times the quantity 2x to the 1/3 minus 5 times the quantity x to the 1/3 plus 4. All right. So for the next one, factor completely. Now both of these are pretty much fair game, except I probably wouldn't do that x to the 0 thing for you on the test. But certainly this substitution idea is fair game for the test. Working with fractional exponents is fair game for the test. This problem here is definitely fair game for the test. So see if you can get it done. Pause the video, see if you can factor it, and then check your answer. Okay, so I'm going to go ahead and go over this. What I'm going to realize is that's got 4 terms. I'm going to try grouping. But I'm going to be very careful because that's a minus sign. I cannot insert parentheses in front of a minus sign. That changes the problem. So I'm going to think of this as plus a minus. And so I'm going to group these two together. And now I'm putting a parentheses in front of a plus sign, and that doesn't change the problem. All right, so I've got my groups. I look for a GCF in each group. So I look at these two and I see r cubed is the GCF. So that would leave me 2r plus p plus, now you want to think ahead here. The whole point of grouping is to get a binomial GCF to factor out in the next step. If you cannot get a binomial GCF to factor out in the next step, grouping didn't help. And you're probably looking at something that can't be factored. So I see that both of these signs are negative, but I need both of the signs to be positive in this binomial here. So whatever GCF I take out, I'm going to take it out as a negative. So let's see, what's common? P cubed. So I'm going to take it out as negative p cubed. And so negative p cubed times what would give me negative 2rp cubed? That would be a positive 2r. Negative p cubed times what would give me negative p to the 4th? That would be a positive p to the 1st. And notice I have the same binomial over in this term. And the other thing you need to notice, and this happens frequently when I give this problem on the test, you're not done. You're not in factored form. See that big fat plus sign? There are still 2 terms. You're not in factored form until you got all one term and all your factors are prime. So now we factor out the binomial GCF. And if you still struggle with factoring out a binomial GCF, use that substitution trick. Let u be that binomial, 2r plus p. So this becomes r cubed u plus a negative p cubed u. And you just factor out the u, you get r cubed minus p cubed. And what's u? Plug that back in and you'll have it. So substitution, you can use that anytime you need it to help you see better what's going on. Now, notice, by the way, the u is common only once. So just like here, I'm not going to use the substitution. I'm going to do it without. The 2r plus p is only common once. So the GCF is just 2r plus p to the 1st. For some reason, people want to make that 2. Open in front of blank parentheses. 2r plus p times what would give me this term back? It would be r cubed. 2r plus p times what will give me this term back? It would be negative p cubed. Okay, and we're still not done. You gotta recognize this factor is not prime. It is the difference of 2 cubes. And the cube roots are r and p. Cube root r, cube root is p, and I'm just gonna follow the pattern. So you have to have that pattern memorized. So first I'm going to copy down the 2r plus p. Then difference of two cubes, it's two factors. The first one's short, and it's just subtract the two cube roots because that's a minus there, so it's r minus p, times, the back factor's long, square the first cube root, r squared. It'll be plus because there's only one minus sign in the answer. Multiply the two cube roots together, don't double, so that's just rp, plus square the second cube root, which would be p squared. And that is factored form. All right, so we'll stop this video. Maybe before you turn on the next video, try these three problems.